try 1, 2 times xy, I'm going to get back xy. So let's see here. So we have x e1 plus 2x e2 e1 plus 1y e1 e2 plus 2y e2 e2, yeah? And so e1 e1 is x times e1 plus e2, and that's 0, that's 0, that's 0. No, that didn't work. I mean, I get x comma x. Did I mess it up? Did I miss something? I mean, I think we need e2 e2 is equal to 1 maybe? Maybe e2 e2 equals e2? Could that work? Because then that gives me this, instead of going to 0, is e2. I get, oh, I don't get y, I get 2y then. Dang it. So e2 over 2, that would at least give me the, that would give me the y here. But I still got it plus x as it currently stands. Yeah? E1, well, yeah, E1, okay, well, then we're back to what he said a minute ago. So you're like, that's, well, yeah, I mean, that's, that will not escape. I mean, that's not going to escape test 3. Case 3 will cover this. I really need something where, oh, that's part of my answer, I guess. I mean, case 3 will cover this, I think. I mean, this, anyway. So that's my problem. I want to believe, but I'm struggling with believing. If I believe, if I accept what I've shown you, if there really is not a goal, if there's not a hole in the argument, it's pretty cool because it gives us this nice, relatively clear path to cycle through, you know, all the two-dimensional algebras that we need to see whether or not a given function can be algebratized. Because algebratizability of the vector field is the same as the question, is the function from R2 to R2 a differentiable for some algebra? And so my native intuition is that I should check, is it a differentiable for all possible two-dimensional algebras? And what he's trying to convince me of is that, no, it's enough to check if it's a differentiable with respect to the case 1, case 2, or case 3 algebras. And I'm just fighting it in my mind, kicking and screaming. I don't know why. Part of it is, I still wonder, even if it is possible, is there something to be gained by understanding that there's a more natural algebra that the problem is directly represented in? I mean, maybe doing this linear algebra finds me a solution that's ugly, whereas if I was to sort through all possible algebras, I would still find something prettier. But that's, anyway, this is what now you know my problems. Oh, that said, the differential equations I showed you guys, like talking to him and Elfeliat Lopez Gonzalez, he has an idea for how to solve those and a couple other ones. And I think I pretty well understand. I just basically check if the system is consistent with the case 1 algebras or the case 2 algebras. But the interesting thing is there's a little bit more to it. Actually, each system you either have to look at the unit being E1 or the unit being E2, and it changes the starting point for the problem. And then we're also looking at problems where we have ux equal to f and vy equal to g. So you have to if you want to work with differentiability where 1 is the unit, you have to change both the x derivative is fine, but the y derivative needs to be changed to an x derivative. So you use the Cauchy-Riemann equations to trade out your x for your y, trade out your y for your x derivative. And I'll show it to you guys once I'm done with it. It's a pretty neat argument. And I really want to believe that this is a general argument because that's pretty neat. I have a way to sort through all possible two-dimensional algebras. I'm sorry. Sort through all possible two-dimensional algebras without actually sorting through all the two-dimensional algebras. Bleh. Anyway, if you guys have some sudden flash of how to convince me to be more logical, let me know. Any questions? So again, my question for you guys is, if you have some time this weekend or the next rest of the week, shoot me an email which topic you want to dig further into that we did earlier. All right? Manifolds. What kind of manifolds? I don't know.
He's worried that if he suggests it, he will
take away from.
I told him to throw it out there because it's sci-fi related to he's really interested in.
Uh-huh.
But
So what kind of manifolds do you want to look? We can hit the